Chapter 4 Climate. We drink more water during summers. Your uniform during the summer is different from the winters. Why do you wear lighter clothes during summers and heavy woolen clothes during winters in North India? In southern India, woolen clothes are not required. In northeastern states, winters are mild except in the hills. There are variations in weather conditions during different seasons. These changes occur due to the changes in the elements of weather, temperature, pressure, wind direction and velocity, humidity and precipitation, etc. Weather is the momentary state of the atmosphere, while climate refers to the average of the weather conditions over a longer period of time. Weather changes quickly, maybe within a day or week, but climate changes imperceptibly and may be noted after 50 years of even or even more. You have already studied about the monsoon in your earlier classes in the previous chapters. You are also aware of the meaning of the word monsoon. Monsoon connotes the climate associated with seasonal reversal in the direction of winds. India has hot monsoonal climate, which is the prevalent climate in South and Southeast Asia. Unity and diversity in the monsoon climate. The monsoon regime emphasizes the unity of India with the rest of Southeast Asian region. This view of broad unity of the monsoon type of climate should not, however, lead one to ignore its regional variations, which differentiate the weather and climate of different regions of India. For example, the climate of Kerala and Tamil Nadu in the south are so different from that of Uttar Pradesh and Bihar in the north, and yet all of these have a monsoon type of climate. The climate of India has many regional variations expressed in the pattern of winds, temperature, and rainfall, rhythm of seasons, and the degree of wetness or dryness. These regional diversities may be described as subtypes of monsoon climate. Let us take a closer look at these regional variations in temperature, winds, and rainfall. While in the summer the mercury occasionally touches 55 degrees Celsius in the western Rajasthan, it drops down to as low as minus 45 degrees Celsius in winter around Leh. Churu in Rajasthan may record a temperature of 50 degrees Celsius or more on a June day, while the mercury hardly touches 19 degrees Celsius in Tawang, Arunachal Pradesh on the same day. On a December night, temperature in Tras Tras Ladakh may drop down to minus 45 degrees Celsius, while Thiruvananthapuram or Chennai on the same night records 20 degrees Celsius, 22 degrees Celsius. These examples confirm that there are seasonal variations in temperature from place to place and from region to region in India. Not only this, if we take only a single place and record the temperature for just one day, variations are no less striking. Kerala and in the Andaman Islands, the difference between day and night temperatures may be hardly 7 or 8 degrees Celsius. But in the Thar Desert, if the day temperature is around 50 degrees Celsius at night, it may drop down considerably up to 15 degree to 20 degrees Celsius. Now let us see the regional variations in precipitation. While snowfall occurs in the Himalayas, it only rains over the rest of the country. Similarly, variations are noticeable not only in the type of precipitation but also in its amount. While Cherrapunji and Mawsynram in the Khasi Hills of Meghalaya receive rainfall over 1080 cm in a year, Jaisalmer in Rajasthan rarely gets more than 9 cm of rainfall during the same period. Tura, situated in the Garo Hills of Meghalaya, may receive an amount of rainfall in a single day which is equal to 10 years of rainfall at Jaisalmer, while the annual precipitation is less than 10 cm in the northwest Himalayas and the western deserts. It exceeds 400 cm in Meghalaya. The Ganga Delta and the coastal plains of Odisha are hit by strong rain-bearing storms almost every third or fifth day in July and August, while the Coromandel coast, 1,000 km to the south coast, generally dry during these months. Most parts of the country get rainfall during June-September, but on the coastal areas of Tamil Nadu, it rains in the beginning of the winter season. In spite of these differences and variations, the climate of India is monsoonal in rhythm and character. Factors determining the climate of India. India's climate is controlled by a number of factors which can be broadly divided into two groups: factors related to location and relief, and factors related to air pressure and winds. Factors related to location and relief. Latitude. You already know the latitudinal and longitudinal extent of the land of India. You also know that the Tropic of Cancer passes through the central part of India in east-west direction. Thus, north This northern part of the India lies in subtropical and temperate zone, and the part lying south of the Tropic of Cancer falls in the tropical zone. The tropical zone, being nearer to the equator, experiences high temperatures throughout the year with small daily and annual range. Area north of the Tropic of Cancer, being away from the equator, experiences extreme climate with high daily and annual range of temperature. The Himalayan mountains, the lofty Himalayas in the north, along with its extensions, act as an effective climatic divide. The towering mountain chain provides an invincible shield to protect the subcontinent from the cold northern winds. These cold and chilly winds originate near the Arctic Circle and blow across Central and Eastern Asia. The Himalayas also trap the monsoon winds, forcing them to shed their moisture within the subcontinent. Distribution of land and water: India is flanked by the Indian Ocean on three sides in the south and girdled by a high and continuous mountain wall in the north. As compared to the landmass, water heats up or cools down slowly. This differential heating of land and sea creates different air pressure zones in different seasons in and around the Indian subcontinent. Difference in air pressure causes reversal in the area in the direction of monsoonal winds. Distance from the sea: with a long coastline, large coastal areas have an equable climate. Areas in the interior of India are far away from the moderating influence of the sea. Such areas have extremes of climate. That is why the people of Mumbai and the Konkan coast have hardly any idea of extremes of temperature and the seasonal rhythm of weather. On the other hand, the seasonal contrast in weather at places in the interior of the country such as Delhi, Kanpur and Amritsar affect the entire sphere of life. Altitude: temperatures decreases with the height due to thin air. Places in the mountains are cooler than places on the plains. For example, Agra and Darjeeling are located on the same latitude, but temperature of January in Agra is 16 degrees Celsius, whereas it is only 4 degrees Celsius in Darjeeling. Relief: the physiography or relief of India also affects the temperature, air pressure, direction and speed of wind, and the amount and distribution of rainfall. The windward sides of Western Ghats and the Assam receive high rainfall during June-September, whereas the southern plateau remains dry due to its leeward situation along the western Ghats. Factors related to air pressure and wind. To understand the differences in local climates of India, we need to understand the mechanism of the following three factors. First, distribution of air pressure and winds on the surface of the earth. Second, upper air circulation caused by factors controlling global weather and the inflow of different air masses and jet streams. Third, inflow of western cyclones, generally known as disturbances, during the winter season and tropical depressions during the southwest monsoon period into India, creating weather conditions favorable to rainfall. The mechanism of these three factors can be understood with reference to winter and summer seasons of the year separately. Mechanism of weather in the winter season: surface pressure and winds. In winter months, the weather conditions over India are generally influenced by the distribution of pressure in Central and Western Asia. High pressure center in the region lying to the north of the Himalayas develops during winter. This center of high pressure gives rise to the flow of air at the low level from the north towards the Indian subcontinent south of the mountain range. The surface winds blowing out of the high pressure center over Central Asia reach India in the form of a dry continental air mass. These continental winds come in contact with trade winds over northwestern India. The position of this contact zone is not, however, stable. Occasionally, it may shift its position as far east as the middle Ganga Valley, with the result that the whole of the northwestern and the northern India up to the middle Ganga Valley comes under the influence of dry northwestern winds, jet streams, and upper air circulation. The pattern of air circulation discussed above is witnessed only at the lower level of the atmosphere near the surface of the earth. Higher up in the lower troposphere, about 3 km above the surface of the earth, a different pattern of air circulation is observed. The variations in the atmospheric pressure closer to the surface of the earth have no role to play in the making of upper air circulation. All of Western Central Asia remains under the influence of westerly winds along the altitude of 9 to 13 km from west to east. These winds blow across the Asian continent at latitudes north of the Himalayas, roughly parallel to the Tibetan highlands. These are known as jet streams. Tibetan highlands act as a barrier in the path of these jet streams. As a result, jet streams get bifurcated. One of its branches flows to the north of the Tibetan highlands, while the southern branch blows in an eastward direction south of the Himalayas. It has its mean position as 25° north in February at 200 to 300 MB level. It is believed that this southern branch of the jet stream exercises an important influence on the winter in on the winter weather in India. Western cyclonic disturbance and tropical cyclones. The western cyclonic disturbances, which enter the Indian subcontinent from the west and the northwest during the winter months, originate over the Mediterranean Sea and are brought into India by the westerly jet stream. An increase in the prevailing night's temperature generally indicates an advance in the arrival of these cyclones disturbances. Tropical cyclones originate over the Bay of Bengal and the Indian Ocean. These tropical cyclones have very high wind velocity and heavy rainfall and hit the Tamil Nadu, Andhra Pradesh and Odisha coast. Most of these cyclones are very destructive due to high wind velocity and torrential rain that accompanies it. Mechanism of weather in the summer season. Surface pressure and winds. As the summer sets in and the sun shifts northwards, the wind circulation over the subcontinent undergoes a complete reversal at both the lower as well as the upper levels. By the middle of July, the low pressure belt nearer the surface, termed as Intertropical Convergence Zone (ITCZ), shifts northwards roughly parallel to the Himalayas between 20° north and 25° north. By this time, the westerly jet stream withdraws from the Indian region. In fact, meteorologists have found an interrelationship between the northward shift of the equatorial trough (ITCZ) and the withdrawal of the westerly jet streams over the North Indian plain. It is generally believed that there is a cause and effect relationship between the two. The ITCZ, being a zone of low pressure, attracts inflow of winds from different directions. The maritime tropical air mass empty from the southern hemisphere after crossing the equator rushes to the low pressure area in the general southwesterly direction. It is this moist air current which is popularly known as the southwest monsoon. Jet streams and upper air circulation. The pattern of pressure and winds as mentioned above is formed only at the level of the troposphere, as an easterly jet stream flows over the southern part of the peninsula in June and has a maximum speed of 90 km per hour. In August, it is confined to 15° north latitude, and in September up to 22° north latitudes. The easterlies normally do not extend to the north of 30° north latitude in the upper atmosphere. Easterly jet stream and tropical cyclones. The easterly jet stream steers the tropical depressions into India. These depressions play a significant role in the distribution of monsoon rainfall over the Indian subcontinent. The tracks of these depressions are the areas of highest rainfall in India. The frequency at which these depressions visit India, the direction and intensity all go a long way in determining the rainfall pattern during the southwest monsoon period. Intertropical Convergence Zone (ITCZ). In the Intertropical Convergence Zone (ITCZ) is a low pressure zone located at the equator where trade winds converge, and so it is a zone where air tends to ascend. In July, the ITCZ is located around 20° north to 25° north latitudes over the Gangetic Plain, sometimes called the monsoon trough. This monsoon trough encourages the development of thermal low over north and northwest India. Due to the shift of ITCZ, the trade winds of the southern hemisphere cross the equator between 40° and 60° east longitudes and start blowing from southwest to northeast due to the Coriolis force. It becomes southwest monsoon in winter. The ITCZ moves southward, and so the reversal of winds from northeast to south and southwest takes place. They are called northeast monsoon. The nature of Indian monsoon. Monsoon is a familiar, though a little known, climatic phenomenon. Despite the observations spread over centuries, the monsoon continues to puzzle the scientists. Many attempts have been made to discover the exact nature and causation of monsoon, but so far no single theory has been able to explain the monsoon fully. A real breakthrough has come recently when it was studied at the global rather than at regional level. Systematic studies of the causes of rainfall in the South Asian region helped to understand the causes and salient features of the monsoon, particularly some of its important aspects, such as first, the onset of the monsoon, second, rain bearing systems, for example, tropical cyclones, and the relationship between their frequency and distribution of monsoon and rainfall, third, break in the monsoon. Onset of the monsoon. Towards the end of the 19th century, it was believed that the differential heating of land and sea during the summer month is the mechanism which sets the stage for the monsoon winds to drift towards the subcontinent. During April and May, when the sun shines vertically over the Tropic of Cancer, the large landmass in the north of Indian Ocean gets intensely heated. This causes the formation of an intense low pressure in the northwestern part of the subcontinent. Since the pressure in the Indian Ocean in the south of the landmass is high, as water gets heated slowly, the low pressure cell attracts the southeast trades across the equator. These conditions help in the northward shift in the position of the ITCZ. The southwest monsoon may thus be seen as a continuation of the southeast trades deflected towards the Indian subcontinent after crossing the equator. These winds cross the equator between the 40° east and 60° east longitudes. The shift in the position of the ITCZ is also related to the phenomenon of the withdrawal of the westerly jet stream from its position over the North Indian plain south of the Himalayas. The easterly jet stream sets in along 15° north latitude only after the western jet stream has withdrawn itself from the region. This easterly jet stream is held responsible for the burst of the monsoon in India. Entry of monsoon into India. The southwest monsoon sets in over the Kerala coast by 1st June and moves swiftly to reach Mumbai and Kolkata between 10th and 13th June. By mid-July, southwest monsoon engulfs the entire subcontinent. Rain-bearing systems and rainfall distribution. There seem to be two rain-bearing systems in India. First originate in the Bay of Bengal, causing rainfall over the plains of North India. Second is the Arabian Sea currents of the south west monsoon, which brings rain to the west coast of India. Much of the rainfall along the western Ghats is orographic, as the moisture is obstructed and forced to rise along the Ghats. The intensity of rainfall over the west coast of India is, however, related to two factors. First, the offshore meteorological conditions. Second, the position of the equatorial jet stream along the eastern coast of Africa. The frequency of the tropical depressions originating from the Bay of Bengal varies from year to year. Their paths over India are mainly determined by the position of ITCZ, which is generally termed as the monsoon trough. As the axis of the monsoon trough oscillates, there are fluctuations in the track and direction of these depressions, and the intensity and the amount of rainfall vary from year to year. The rain, which comes in spells, displays a declining trend from west to east over the west coast and from the southeast towards the northwest over the North Indian plain and the northern part of the peninsula. El Nino and the Indian monsoon. El Nino is a complex weather system that appears once every 3 to 7 years, bringing drought, floods, and other weather extremes to different parts of the world. The system involves oceanic and atmospheric phenomena with the appearance of warm currents off the coast of Peru in the eastern Pacific and affects weather in many places, including India. El Nino is merely an extension of the warm equatorial current, which gets replaced temporarily by cold Peruvian current or Humboldt current. This current increases the temperature of water on the Peruvian coast by 10 degrees Celsius. This results in first, the distortion of equatorial atmospheric circulation, second, irregularities in the evaporation of sea water, third, reduction in the amount of planktons, which further reduces the number of fish in the sea. The word El Nino means child Christ because this current appears around Christmas in December. December is a summer month in Peru's southern hemisphere. El Nino is used in India for forecasting long range monsoon rainfall. In 1990 to 91, there was a wild El Nino event, and the onset of southwest monsoon was delayed over most parts of the country, ranging from 5 to 12 days. Break in the monsoon. During the southwest monsoon period, after having rains for a few days, if rainfall fails to occur for one or more weeks, it is known as break in the monsoon. These dry spells are quite common during the rainy season. These breaks in the different regions are due to different reasons. First, the North India rains are likely to fail if the rain-bearing storms are not very frequent along the monsoon trough or the ITCZ over this region. Second, over the west coast, the dry spells are associated with days when winds blow parallel to the coast. The rhythm of seasons. The climatic conditions of India can best be described in terms of an annual cycle of seasons. The meteorologists recognize the following four seasons. First, the cold weather season. Second, the hot weather season. Third, the southwest monsoon season. Fourth, the rotating monsoon season. The cold weather season. Temperature. Usually, the cold weather season sets in by mid-November in northern India. December and January are the coldest months in the northern plain. The mean daily temperature remains below 21 degrees Celsius over most parts of northern India. The night temperature may be quite low, sometimes going below freezing point in Punjab and Rajasthan. There are three main reasons for the excessive cold in North India during this season. First, states like Punjab, Haryana, and Rajasthan, being far away from the moderating influence of sea, experience continental climate. Second, the snowfall in the nearby Himalayan ranges creates cold wave situation. And third, around February, the cold winds coming from the Caspian Sea and Turkmenistan bring cold wave along the frost and fog over the northwestern parts of India. Understanding the monsoon. Attempts have been made to understand the nature and mechanism of the monsoon on the basis of data collected on land, oceans, and in the upper atmosphere. The intensity of southwest monsoon winds of southern oscillation can be measured, and among others, by measuring the difference in pressure between Tahiti, roughly 20 degrees south and 140 degrees west, in French Polynesia, in East Pacific, and Port Darwin, 20 degree 30 minutes south and 131 degree east in northern Australia. Indian Meteorological Department can forecast the possible behavior of monsoons on the basis of 16 indicators. The peninsular region of India, however, does not have any well defined cold weather season. There is hardly any seasonal change in the distribution pattern of the temperature in coastal areas because of moderating influence of the sea and the proximity to equator. For example, the mean maximum temperature for January at Thiruvananthapuram is as high as 31 degrees Celsius, and for June it is 29.5 degrees Celsius. Temperatures at the hills of Western Ghats remain comparatively low. Pressure and winds. By the end of December 2nd December, the sun shines vertically over the Tropic of Capricorn in the southern hemisphere. The weather in this season is characterized by feeble high pressure conditions over the northern plain. In South India, the air pressure is slightly lower. The isobars of 1019 MB and 1013 MB pass through northwest India and far south respectively. As a result, winds start blowing from northwestern high pressure zone to the low air pressure zone over the Indian Ocean in the south. Due to low pressure gradient, the light winds with a low velocity of about 3 to 5 km per hour begin to blow outwards. By and large, the topography of the region influences the wind direction. They are westerly or northwesterly down the Ganga Valley. They become northerly in the Ganga Brahmaputra Delta, free from the influence of topography. They are clearly northeasterly over the Bay of Bengal. During the winters, the weather in India is pleasant. The pleasant weather conditions, however, at intervals get disturbed by shallow cyclonic depressions originating over the East Mediterranean Sea and traveling eastwards across West Asia, Iran, Afghanistan, and Pakistan before they reach the northwestern parts of India. On their way, the moisture content gets augmented from the Caspian Sea in the north and the Persian Gulf in the south. Rainfall. Winter monsoons do not cause rainfall as they move from land to the sea. It is because, firstly, they have little humidity, and secondly, due to anticyclonic circulation on land, the possibility of rainfall from them reduces. So, most parts of India do not have rainfall in the winter season. However, there are some exceptions to it. First, in northwestern India, some weak temperate cyclones from the Mediterranean Sea caused rainfall in Punjab, Haryana, Delhi, and western Uttar Pradesh. Although the amount is meager, it is highly beneficial for rabi crops. The precipitation is in the form of snowfall in the lower Himalayas. It is this snow that sustains the flow of water in the Himalayan rivers during the summer months. The precipitation goes on decreasing from west to east to the in the plains and from north to south in the mountains. The average winter rainfall in Delhi is around 53 millimeter. In Punjab and Bihar, rainfall remains between 25 millimeter and 18 millimeter respectively. Second, central parts of India and northern parts of southern peninsula also get winter rainfall occasionally. Third, Arunachal Pradesh and Assam in the northeastern parts of India also have rains between 25 millimeter and 50 millimeter during these winter months. Fourth, during October and November, northeast monsoon, while crossing over the Bay of Bengal, picks up moisture and causes torrential rainfall over the Tamil Nadu coast, southern Andhra Pradesh, southeast Karnataka, and southeast Kerala. The hot, the hot weather season temperature. With the apparent northward movement of the sun towards the Tropic of Cancer in March, temperatures start rising in North India. In April, May, and June are the months of summer in North India. In most parts of India, temperatures recorded are between 30 degree to 32 degrees Celsius. In March, the highest temperature of about 38 degrees Celsius occurs in the Deccan Plateau, while in April, temperature ranging between 38 degrees Celsius and 43 degrees Celsius are found in Gujarat and Madhya Pradesh. In May, the heat belt moves further north, and in the northwestern part of India, temperatures around 48 degrees Celsius are not uncommon. The hot weather season in South India is mild and not so intense as found in North India. The peninsular situation of South India, with moderating effect of the oceans, keeps the temperatures lower than that prevailing in North India. So temperatures remain between 26 degrees Celsius and 32 degrees Celsius. Due to altitude, the temperatures in the hills of Western Ghats remain below 25 degrees Celsius. In the coastal regions, the north-south extent of isotherms parallel to the coast confirms the temperature does not decrease from north to south, rather it increases from the coast to the interior. The mean daily minimum temperature during the summer months also remains quite high and rarely goes below 26 degrees Celsius. Pressure and winds. The summer months are a period of excessive heat and falling air pressure in the northern half of the country. Because of the heating of the subcontinent, the ITCZ moves northwards, occupying a position centered at 25° north in July. Roughly, this elongated low pressure monsoon trough extends over the Thar Desert in the northwest to Patna and Chota Nagpur Plateau in the east southeast. The location of the ITCZ attacks the surface circulation of the winds, which are southwesterly on the west coast as well as along the coast of West Bengal and Bangladesh. They are easterly or southeasterly over North Bengal and Bihar. It has been discussed earlier that these currents of southwesterly monsoon are in reality displaced equatorial easterlies. The influx of these winds by mid-June brings about a change in the weather towards the rainy season. In the heart of the ITCZ in the northwest, the dry and hot winds known as Lu blow in the afternoon, and very often they continue to well into midnight. Dust storms in the evening are very common during May in Punjab, Haryana, eastern Rajasthan, and Uttar Pradesh. These temporary storms bring a welcome respite from the oppressing heat, since they bring with them light rains and a pleasant cool breeze. Occasionally, the moisture-laden winds are attracted towards the periphery of the trough. A sudden contact between dry and moist air masses gives rise to local storms of great intensity. These local storms are associated with violent winds, torrential rains, and even hailstorms. Some famous local storms of hot weather season. First, mango shower. Towards the end of summer, there are pre-monsoon showers, which are a common phenomenon in Kerala and coastal areas of Karnataka. Locally, they are known as mango showers since they help in the early ripening of mangoes. Second, blossom shower. With this shower, coffee flowers blossom in Kerala and nearby areas. Third, nor'westers. These are dreaded evening thunderstorms in Bengal and Assam. Their notorious nature can be understood from the local nomenclature of Kalbaisakhi, a calamity of the month of Baisakh. These showers are useful for tea, jute, and rice cultivation. In Assam, these storms are known as Bardoi Sela. 4. Lu, hot, dry, and oppressing winds blowing in the northern plains from Punjab to Bihar with higher intensity between Delhi and Patna. The southwest monsoon season. As a result of rapid increase of temperature in May over the northwestern plains, the low pressure conditions over there get further intensified. By early June, they are powerful enough to attract the trade winds of southern hemisphere coming from the Indian Ocean. These southeast trade winds cross the equator and enter the Bay of Bengal and the Arabian Sea only to be caught up in the air circulation over India. Passing over the equatorial warm currents, they bring with them moisture in abundance. After crossing the equator, they follow a southwesterly direction. That is why they are known as southwest monsoons. The rain in the southwest monsoon season begins rather abruptly. One result of the first rain is that it brings down the temperature substantially. This sudden onset of the moisture laden winds associated with violent thunder and lightning is often termed as the break or burst of the monsoons. The monsoon may burst in the first week of June in the coastal areas of Kerala, Karnataka, Goa, and Maharashtra, while in the interior parts of the country it may be delayed to the first week of July. The day temperature registers a decline of 5 degrees Celsius to 8 degrees Celsius between mid June and mid July. As these winds approach the land, their southwesterly direction is modified by the relief and thermal low pressure over the northwest India. The monsoon approaches the landmass in two branches. First, the Arabian Sea branch, second, the Bay of Bengal branch. Monsoon winds of the Arabian Sea. The monsoon winds originating over the Arabian Sea further split into three branches. First, over its one branch is obstructed by the Western Ghats. These winds climb the slopes of the Western Ghats from 900 to 1200 meters. Soon they become cool, and as a result, the windward side of the Sahyadris and western coastal plain receive very heavy rainfall ranging between 250 cm and 400 cm. After crossing the Western Ghats, these winds descend and get heated up. This reduces humidity in the winds. As a result, these winds cause little rainfall east of the Western Ghats. This region of low rainfall is known as the rain shadow area. Second, another branch of the Arabian Sea monsoon strikes the coast north of Mumbai, moving along the Narmada and Tapi river valleys. These winds cause rainfall in extensive areas of central India. The Chota Nagpur plateau gets 15 cm rainfall from this part of the branch. Thereafter, they enter the Ganga plains and mingle with the Bay of Bengal branch. Third, a third branch of this monsoon wind strikes the Saurashtra Peninsula and the Kutch. It then passes over West Rajasthan and along the Aravallis, causing only a scanty rainfall in Punjab and Haryana. It too joins the Bay of Bengal branch. These two branches, reinforced by each other, cause rains in the western Himalayas. Monsoon winds of the Bay of Bengal. The Bay of Bengal branch strikes the coast of Myanmar and part of southeast Bangladesh, but the Arakan hills along the coast of Myanmar deflect a big portion of this branch towards the Indian subcontinent. The monsoon therefore enters West Bengal and Bangladesh from south and southeast instead of from the southwesterly direction. From here, this branch splits into two under the influence of the Himalayas, and the thermal low is northwest India. Its one branch moves westward along the Ganga plains, reaching as far as the Punjab plains. The other branch moves up the Brahmaputra valley in the northern and the northeast, causing widespread rains. Its sub-branch strikes the Garo and Khasi hills of Meghalaya. Mawsynram, located on the crest of Khasi hills, receives the highest average annual rainfall in the world. Here it is important to know why the Tamil Nadu coast remains dry during this season. There are two factors responsible for it. First, The Tamil Nadu coast is situated parallel to the Bay of Bengal branch of southwest monsoon. Second, it lies in the rain shadow area of the Arabian Sea branch of the southwest monsoon. Characteristics of monsoonal rainfall. First, rainfall received from the southwest monsoons is seasonal in character, which occurs between June and September. Second, monsoonal rainfall is largely governed by relief or topography. For instance, the windward side of the Western Ghats register a rainfall of over 250 cm. Again, the heavy rainfall in the north eastern states can be attributed to their hill ranges and the eastern Himalayas. Third, the monsoon rainfall has a declining trend with increasing distance from the sea. Kolkata receives 119 cm during the southwest monsoon period, Patna 105 cm, Allahabad 76 cm, and Delhi 56 cm. 4. The monsoon rains occur in wet spells of few days duration at a time. The wet spells are interspersed with rainless interval known as breaks. These breaks in rainfall are related to the cyclonic depressions mainly formed at the head of the Bay of Bengal and the crossing into the mainland. Besides the frequency and intensity of these depressions, the passage followed by them determines the spatial distribution of rainfall. 5. The summer rainfall comes in a heavy downpour leading to considerable runoff and soil erosion. 6. Monsoons play a pivotal role in the agrarian economy of India because over three-fourths of the total rain in the country is received during the southwest monsoon season. 7. Its spatial distribution is also uneven, which ranges from 12 cm to more than 250 cm. 8. The beginning of the rain sometimes is considerably delayed over the whole or a part of the country. 9. The rains sometimes end considerably earlier than usual, causing great damage to standing crops and making the sowing of winter crops difficult. Season of retreating monsoon. The months of October and November are known for retreating monsoons. By the end of September, the southwest monsoon becomes weak as the low pressure trough of the Ganga plain starts moving southward in response to the southward march of the sun. The monsoon retreats from the western Rajasthan by the first week of September. It withdraws from Rajasthan, Gujarat, western Ganga plain, and the central highlands by the end of the month. By the beginning of October, the low pressure covers northern parts of the Bay of Bengal, and by early November, it moves over Karnataka and Tamil Nadu. By the middle of December, the center of low pressure is completely removed from the peninsula. The retreating southwest monsoon season is marked by clear skies and rise in temperature. The land is still moist owing to the conditions of high temperature and humidity. The weather becomes rather oppressive. This is commonly known as the October heat. In the second half of October, the mercury begins to fall rapidly, particularly in northern India. The weather in the retreating monsoon is dry in North India, but it is associated with rain in the northeastern part of the peninsula. Here, October and November are the rainiest months of the year. The widespread rain in this season is associated with the passage of cyclonic depressions, which originate over the Andaman Sea and manage to cross the eastern coast of the southern peninsula. These tropical cyclones are very destructive. The thickly populated deltas of the Godavari, Krishna, and Kaveri are their preferred targets every year. Every year, cyclones bring disaster here. A few cyclonic storms also strike the coast of West Bengal, Bangladesh, and Myanmar. A bulk of the rainfall of the Coromandel coast is derived from these depressions and cyclones. Such cyclonic storms are less frequent in the Arabian Sea. Traditional Indian seasons. In the Indian tradition, a year is divided into 6 2 monthly seasons. This cycle of seasons, which the common people in North and Central India follow, is based on the practical experience and age-old perception of weather phenomena. However, this system does not match with the seasons of South India, where there is little variation in the seasons. Distribution of rainfall. The average annual rainfall in India is about 125 cm, but it has great spatial variations. Areas of high rainfall. The highest rainfall occurs along the west coast on the western Ghats as well as in the sub-Himalayan areas in the northeast and in the hills of Meghalaya. Here the rainfall exceeds 200 cm. In some parts of Khasi and Jaintia hills, the rainfall exceeds 1000 cm. In the Brahmaputra valley and the adjoining hills, the rainfall is less than 200 centimeter. Areas of medium rainfall, rainfall between 100 to 200 centimeters is received in the southern parts of Gujarat, East Tamil Nadu, northeastern peninsula covering Odisha, Jharkhand, Bihar, eastern Madhya Pradesh, northern Ganga plain, along the sub-Himalayas and the Kachar Valley and Manipur. Areas of low rainfall, western Uttar Pradesh, Delhi, Haryana, Punjab, Jammu and Kashmir, eastern Rajasthan, Gujarat and Deccan Plateau received rainfall between 50 to 100 centimeter. Areas of inadequate rainfall, parts of the peninsula, especially in Andhra Pradesh, Karnataka and Maharashtra, Ladakh and most of western Rajasthan received rainfall below 50 centimeter. Snowfall is restricted to the Himalayan region. Identify the pattern of rainfall after consulting the rainfall map. Variability of rainfall. A characteristic feature of rainfall in India is its variability. The variability of rainfall is computed with the help of the following formula. CV is equal to standard deviation by mean into 100, where CV is the coefficient variation. The values of coefficient of variation show the change from the mean values of rainfall. The actual rainfall in some places deviates from 20 to 50%. The values of coefficient of variation show variability of rainfall in India. A variability of less than 25% exists on the western coast, Western Ghats, northeastern peninsula, eastern plains of the Ganga, northeastern India, Uttarakhand and Himachal Pradesh, and south western part of Jammu and Kashmir. These areas have an annual rainfall of over 100 centimeter. Variability of over 50% exists in the western part of Rajasthan, northern part of Jammu and Kashmir and interior parts of the Deccan Plateau. These areas have an annual rainfall of less than 50 centimeter. Rest of India have a variability of 25 to 50% and these areas receive an annual rainfall between 50 to 100 centimeter. Climatic regions of India. The whole of India has a monsoon type of climate, but the combination of elements of the weather, however, reveal many regional variations. These variations represent the subtypes of the monsoon climate. It is on this basis that the climatic regions can be identified. A climatic region has a homogeneous climatic condition which is the result of a combination of factors. Temperature and rainfall are two important elements which are considered to be decisive in all the schemes of climatic classification. The classification of climate, however, is a complex exercise. There are different schemes of classification of climate. Major climatic types of India based on Köppen's scheme have been described, such as Köppen based his scheme of climatic classification on monthly values of temperature and precipitation. He identified five major climatic types, namely first, tropical climates where mean monthly temperature throughout the year is over 18 degrees Celsius. Second, dry climates where precipitation is very low in comparison to temperature and hence dry. If dryness is less, it is semi-arid, as if it is more, the climate is arid. W. Third, warm temperature climates where mean temperature of the coldest month is between 18 degrees Celsius and minus 3 degrees Celsius. 4, cool temperature climates where mean temperature of the warmest month is over 10 degrees Celsius and mean temperature of the coldest month is under minus 3 degrees Celsius. 5, ice climates where mean temperature of the warmest month is under 10 degree Celsius. Köppen used letter symbols to denote climatic types as given above. Each type is further subdivided into subtypes on the basis of seasonal variations in the distribution pattern of rainfall and temperature. He used S for semi-arid and W for arid and the following small letters to define subtypes. F, sufficient precipitation, and M, rainforest despite a rainy dry monsoon season. W, dry season in winter, and H, dry and hot. C, less than 4 months with mean temperature over 10 degrees Celsius, and G, Gangetic plain. Accordingly, India can be divided into 8 climatic regions. Monsoons and economic life in India. First, monsoon is that axis around which revolves the entire agricultural cycle of India. It is because about 64% people of India depend on agriculture for their livelihood and agriculture itself is based on southwest monsoon. Second, except Himalayas, all the parts of the country have temperature above the threshold level to grow the crops or plants throughout the year. Third, regional variations in monsoon climate help in growing various types of crops. Fourth, variability of rainfall brings droughts or floods every year in some parts of the country. 5, agricultural prosperity of India depends very much on timely and adequately distributed rainfall. If it fails, agriculture is adversely affected, particularly in those regions where means of irrigation are not developed. 6. Sudden monsoon burst creates problem of soil erosion over large areas in India. 7. Winter rainfall by temperate cyclones in North India is highly beneficial for rabi crops. 8. Regional climatic variation in India is reflected in the vast variety of food, clothes, and house types. Global warming. You know that change is the law of nature. Climate has also witnessed change in the past at the global as well as local levels. It is changing even now, but the change is imperceptible. A number of geological evidences suggest that once upon a time, large part of the earth was under ice cover. Now you might have read or heard the debate on global warming. Besides the natural causes, human activities such as large scale industrialization and presence of polluting gas in the atmosphere and are also important factors responsible for global warming. You might have heard about the greenhouse effect while discussing global warming. The temperature of the world is significantly increasing. Carbon dioxide produced by human activities is a major source of concern. This gas released to the atmosphere in large quantities by burning of fossil fuel is increasing gradually. Other gases like methane, chlorofluorocarbons, and nitrous oxide, which are present in much smaller concentrations in the atmosphere together with carbon dioxide, known as greenhouse gases. These gases are better absorbers of long wave radiations than carbon dioxide, and so are more effective in enhancing the greenhouse effect. These gases have been contributing to global warming. It is said that due to global warming, the polar ice caps and mountain glaciers would melt, and the amount of water in the oceans would increase. The mean annual surface temperature of the Earth in the past 150 years has increased. It is projected that by the year 2100, global temperature will increase by about 2 degrees Celsius. This rise in temperature will cause many other changes. One of these is a rise in sea level as a result of melting of glaciers and sea ice due to warming. According to the current prediction, on an average, the sea level will rise 48 centimeter by the end of 21st century. This would increase the incidence of annual flooding, and climatic change would promote insect-borne diseases like malaria and lead to shift in climatic boundaries, making some regions wetter and others drier. Agricultural pattern would shift and human population as well as the ecosystem would experience change. What would happen to the Indian sea coast if the sea level rises 50 centimeter above the present one? Climatic regions of India according to Köppen's scheme. Type of climate and areas. AMW monsoon with short dry season for this area, west coast of India, south of Goa. AS monsoon with dry summer, Coromandel, coast of Tamil Nadu. AW tropical savanna, most of the peninsular plateaus south of the Tropic of Cancer. BSHW semi-arid steppe climate, northwestern Gujarat, some parts of western Rajasthan and Punjab. BWHW hot desert, extreme western Rajasthan. CWG monsoon with dry winter, Ganga plain, eastern Rajasthan, northern Madhya Pradesh, most of northeast India. DFC cold humid winter with short summer, Arunachal Pradesh. E polar type, Jammu and Kashmir, Himachal Pradesh and Uttarakhand.